Hi everyone, it's Miss Amfini here. Today we are beginning a new unit, and we can call this Unit 6, and it's really going to be called Systems of Equations. Today we're going to talk about systems of linear equations. The first thing that we need to understand is first, what is a system of linear equations? Well, a system of linear equations is simply a collection of two or more lines. So here's an example of two lines on a graph. Here's another example of two lines on the graph. Now, when we talk about a solution to a systems of equations, we're talking about their point of intersection. So we can go ahead and put point in here. So let's just read that in with the word now. It says, the solution to a system of linear equations is the point of intersection of all the lines in that system. So let's look at this first example up here. This line here intersects with this line here at this point here, which I'll highlight in red. So if you want to find the solution to this system of equations, you just have to write that point. So let's write underneath solution is equal to 2, 0. Remember, we're writing it as a point. It's a solution. It's a point of intersection. And now let's look at example number 2, this example over here. These lines are what we call parallel. Just as a review from Algebra 1, parallel lines must have the same slope. So look, the slope of this line is 2, and the slope of this line is 2. So they're never going to intersect. Therefore, since there's no point of intersection, there is no solution to this system. Okay? Now, throughout the course of this lesson, we are going to solve these systems algebraically. But before we can do that, I need to talk about types of solutions. This is new vocabulary that you haven't seen before, so this might be a good thing after this lesson. You might want to put them on index cards. So let's start with the word consistent. A consistent system has at least one point of intersection. So let's label that. Okay, so a consistent system has at least one point of intersection. Okay, so let's look over here under where it says consistent. So we can have an independent consistent system where there's one solution. See how these two lines intersect and it's one point of intersection. We could also have a dependent consistent system where the two lines that you graph are the same line. So it helps if you just draw like one line like this on top of the other line. So the first line we'll say is in red and the second line is in blue. So if they're the exact same line, they intersect at every single point on that line. So back up here where it says an independent consistent system, that's this one, has blank of intersection. We would say has one point of intersection. And then when we talk about a dependent consistent system, a dependent consistent system has infinitely many points of intersection. So that's what we're going to put in here. All right. And now we're going to talk about a system that we call inconsistent. So a system that's inconsistent is basically when I have two parallel lines drawn on a graph. What happens? How many points of intersection do I have? You should be saying none. So the inconsistent system has no points of intersection. Okay, we're going to move on to the next page. And the next page, we are going to solve systems of linear equations algebraically. So at this moment, you must have your calculator out. So please pause the video and grab your calculator so that you're ready to go. Okay, so when solving linear systems algebraically, what we're solving for is the point of intersection. So let's maybe write that somewhere over here. Point of intersection. So we're trying to find an x value, comma, a y value. Now, as you notice, we have method 1, method 2, and on the next page we have method 3. There are 3 different ways that you can go about solving systems of linear equations, And in Algebra 2, it's important to know all three methods so that you can pick the right method for the right type of situation. So let's look at example number 1. So in this example, we have both equations. We've got y equals negative 1/2 x plus 10 and y equals 4x minus 6. So if both equations, which are lines by the way, in mx plus b form, if both equations are set equal to y, if y equals this stuff and y also equals this stuff, these two things have to be equal. So we say if they're both set equal to y, we can set them equal to each other. So we would put negative 1/2 x plus 10 equals 4x minus 6. And we would just solve this equation just like we normally would. So the goal is to get x's on one side, numbers on the other. So there are many ways to start off this problem. I'm going to add 1/2 x to both sides. That's my personal choice. So these two would cancel. What am I left with? Well, you should be saying 10 equals. Now, I need everyone to put this into their calculators. I know 4 plus a half is 4.5, but I'm not worrying about decimals. In Algebra 2, we want to work with fractions. So please type in 4 plus 1/2 and hit math, enter, enter, so that you get a simplified fraction. Pause the video until you've done so. Okay, your answer should be 9/2x minus 6. If you didn't get 9/2, I know you can't ask me questions right now, but hold off and at least try to understand the concept moving forward, and we'll get that computational stuff worked out in class tomorrow. So now we want to get this x by itself. So we need to subtract, well, we have a subtracting of 6. We need to add that 6 to both sides to get rid of it. So we're left with 16 equals 9/2x. Okay. Now from this point, some of you may have learned to multiply both sides by 2/9. That's fine. I'm just going to do it the old-fashioned way, and I'm going to divide both sides by 9/2. Okay, here comes a calculator step again. Please, please, please make sure you're putting this into the calculator right now. So what I would type in is 16 divided by 9/2. But how would I put this 9/2 in the calculator? You want to put the 9/2 in parentheses to make sure you get the correct answer. So again, it should be 16 divided by parentheses 9/2. When you do that, you should be getting that x equals 32/9. Now, what did you just solve for? Well, you solved for the x value of this point of intersection. So on the bottom where it says the solution to this system is what? We already have the x value. It's 32/9. So the x value of this point of intersection is already solved for. So what are you missing to finish the problem? Well, you should be saying I need a y value. So we have two equations here. It doesn't matter which of these two equations that you use to find the y value. So I'm going to pick one. I'm going to pick the second one. So y equals 4x minus 6. I chose that one because it didn't have the fraction. But if you chose the top one, you would still get the same answer. So what we're going to do is we're going to plug in this x value into this x right here to find my corresponding y value. So let's write y equals 4. X value is 32/9 minus 6. Now again, please pause the video, put this entire thing into the calculator just the way you see it, and get me a reduced fraction. Hit resume when you've done so. Okay, your answer should be 74/9. So this is the y value, 74/9, of the point of intersection. So I know that these are weird and funky decimals, but that's okay. This is your point of intersection. Now, the next question is this system inconsistent or consistent? Well, inconsistent, recall from the front, means that they're parallel and they don't intersect. Well, they intersect because I have a point of intersection right here, so the answer is that it's consistent. Okay, let's recap what we just did. We are trying to find the point of intersection of these two lines. So we saw that both equations were set equal to y. So if they're both set equal to y, we can set them equal to each other. So we did that, and we solved, and we got an x value. And now we need to find the y value. So to find the y value, I picked any of these two equations. I chose the bottom one, and I substituted the x that I just got from the first spot. And I got 74/9. And then I put this x and this y together and made a point. Some of this should be familiar because you did this in Algebra 1, but if not, don't worry and we'll practice it. Okay, let's move on to example number 2. So this method is called substitution. Now if you notice, this given information, the first equation, is given in y equals form, but the second equation is not given in y equals form. If you really wanted to, you could absolutely solve this second equation for y equals and then set these two equal to each other. But sometimes it's important to use another method. So I want you to recognize what I have here. I have this top equation solved for y, and I have this equation down here. So do you agree that if I rewrite the second equation, I could substitute if y equals 3/4 x minus 4, can I put this y in for this y? This is the name substitution. That's where this is coming from. So if y equals 3/4 x minus 4, all I'm going to do is take that and plug it into this y here. So 3/4 x minus 4. And bring down everything else. So bring down the 2x, the 4, equal sign, and the 24. Now I can simply solve this equation for x. So first we have to distribute this. Now I want you to recognize that 4 times 3/4 is really the same thing as saying 3. Now where did I get that from? And how did I do it so fast? Well, technically this 4 is the same thing as saying 4/1. And technically, when I'm multiplying these fractions, any top with any bottom can cancel. So these 4's cancel, and that's where I get the 3 from. If that's confusing for you, all you need to do in your calculator is multiply 4 times 3/4. So if you're not sure, put that in. And I'll just put it over here. You would be putting in 4 times 3/4. So you put that into the calculator, and I guarantee you'll get 3. Okay, now let's do 4 times -4. That's easy, -16. And bring down the equal sign, the 24, the 2x, and the plus. Oh, this needs an x. Okay, combine like terms. 2x plus 3x should give you 5x. So 5x minus 16 equals 24. Add 16. This should be easy. 5x equals 40. Divide by 5. X equals 8. So again, what did you solve for? You solved for the x value of the point of intersection. So we can go ahead and put the 8 right in there. Now we need to find the y value of the point of intersection. So again, here are the two equations. You can choose any of the two equations that you want. For me, the easier equation is the one that's already solved for y. So y equals 3/4x minus 4. So we're going to substitute the x that we got here, which is 8. So 3/4, 8 minus 4. Take a minute, pause the video, plug this into the calculator, and hit resume once you've done so. And your answer should be 2. So this is the y value of the point of intersection. So my point of intersection is 8, 2. And this system is definitely consistent because it has a point of intersection. Okay, let's look at the last example. Okay, the last example uses the method called elimination. If you notice, both of these equations are not even set equal to y. So we really can't substitute and we can't set them equal to each other. But what we can try to do is eliminate one of the variables. So how about this is a little trick that we teach us, is we could multiply this top equation by 3 and this bottom equation by 5. That trick is found by basically you're taking the coefficient in front of the x, bringing it here. And you're taking the coefficient in front of the x here and bringing it up here. That way, if I distribute this 3 into the top, 3 times 5x is 15x. And 5 times 3x is 15x. So by doing that, I can eliminate these two equations. But the catch is that one of them needs to be negative. I don't care which one's negative. I say we make the bottom one negative. So we'll make it -5. Okay, so we're going to rewrite the top equation by distributing out this 3 into all of the pieces. So 3 times 5x is 15x. 3 times 4y is 12y. And then 3 times -30 is -90. Okay, now we're going to distribute this 5 into all 3 pieces. So -5 times 3 is -5, 15x. And then -5 times -9y is positive 45y. And then 5 times -18 is -90. I'm sorry, -5 times -18 is positive 90. So I've rewritten these equations, and now it's beautiful because all I have to do is add these two equations, and what happens? What's 15 plus -15? You should say these cancel, hence the name elimination. So again, if you take the coefficient 5, bring it down here, take the coefficient 3, bring it up here, and make one of them negative, you have the ability to cancel out those first variables. And now we add the rest of the equations. So 12 plus 45, you should be saying is 57y equals -90 plus 90. You should be saying is 0. Don't freak out. Still solve it like regular. Divide 57 on both sides. So y is equal to 0. So we found the y value of the point of intersection. So I'm going to put 0 there. And now again, to find the x value of the point of intersection, we could pick any of these two equations that we want. So let's pick the top one. 5x plus 4y equals -30. So 5x plus 4y, I'm substituting y this time, and 5x plus 0, because 4 times 0 is 0, equals -30, divide by 5, x equals -6. So I found the x value of the point of intersection. So the point of intersection is -6, and since there's an actual point, it's a consistent system. Okay, so let's try this concept check on our own. I want you to pause the video, and I want you to try. I want you to pick methods 1, 2, or 3 to solve this one. Try it all on your own, and then hit resume for the answer. Okay, here's your answer. Look it over, and come in tomorrow with questions.